Good morning, everybody. I think we've started. Welcome to our webinar this morning to talk about the realities and results of collections and use of AI in collections. A very interesting topic given what's been happening recently. I'm pleased to say that today I'm joined by Konstantinos Kentretis from EXUS, who is, I would say, an expert on AI, certainly compared to me, Kostas. So I'm looking forward to our conversation this morning. Hopefully most of you will know from previous conversations, my name is Farid Mir, and I'm head of advisory from Arum. I lead our advisory team helping clients across the world to improve their collections and recoveries capabilities and performance. Arum as a company, we've been around for well over 25 odd years, and we have a scheme called Arum Approved where we review collection systems and award them accreditation against our criteria. And I'm pleased to say EXUS EFS is one of those Arum Approved systems. Right, so let's get into it. So thank you for joining us this morning, Konstantinos.
Thank you for having me.
Introduce yourself and tell us a bit about EXUS.
Sure. My name is Konstantinos Kentretis. So I've been conducting AI research for EXUS for approximately the past 6 years. Now I'm holding the role of AI product manager. My background is in electrical and computer engineering, and please let me share a few words about EXUS. So EXUS offers debt collections and recovery technology that manages risk along the whole life cycle of accounts. We're a global leader in this field. We've got more than 65 global customers across 45 countries. We estimate serving about 10,000 users, which is amazing. So, and since we're talking about AI, please allow me to also say that we've got a department that is dedicated to AI research. It's called AI Labs, and also a dedicated AI team within the product engineering department. So AI is obviously of very high importance to us and is becoming an integral part of our software.
Right. Okay. So let's start talking a bit about AI. Okay. And let's see that we are both real, just in case anyone is wondering. We're not a figment of some machine somewhere in Silicon Valley. Look, a lot's been happening recently, certainly with lots of new sort of vendors coming into the market. Tell us a bit about what's been happening and some of the trends that you've seen in the market.
All right. First of all, let us define AI as any computational system that uses that performs tasks that would normally require human intelligence. I think we can all understand that. Stuff like problem solving, reasoning, learning, decision making, and all these sorts of things. AI is present since a long time ago. Already modern AI appeared since the 1970s, with the first big breakthroughs in AI appearing in the 1990s. But the biggest rise of machine learning and deep learning, we'll explain what these words are later on, appearing in the 2000s. Now, AI has become so, let's say, a big fuss around AI. And why this big fuss happened? Because first of all, we've been collecting data for a long time due to the digitalization of systems. So we've been collecting data, we've got enough data, which is the fuel for AI. We've got decent infrastructure, so computational capacity and power to perform all the necessary processes and decent hardware. And third and most importantly, AI is now becoming accessible. As you know, probably you've heard about OpenAI, DeepSeek, LLMs, and all that. So that means that we've got a paradigm shift from instruction-based computing, where you need a lot of coding and programming background, to intent-based computing, where you can just do some kind of prompt engineering. So basically, share your intent with the AI and let it handle the rest. So these are the reasons why AI has become so popular nowadays. Now, what types of AI we have? AI will always have some fundamental AI technologies, and these are machine learning. For instance, in the deck that you're sharing, predictive analytics, reinforcement learning, and supervised learning. Predictive analytics, regression classification, supervised learning, all these are machine learning. We've got natural language processing, which is the first bit in the slide, and also we've got computer vision. Now, we've got a lot of AI technologies that are based on these fundamentals. And generative AI part of which are the LLMs, the large language models, of which you also to which you referred earlier, are derivatives that are based on these fundamentals and use different sorts of technologies. We can go into more detail later on if we have the time. So, and another AI field that is becoming very popular nowadays is explainable AI that uses mainly LLMs in order to, so we're asking AI to tell us what, how, and based on which data they performed what they performed.
Okay, thank you. Just to remind our audience, I'll be asking Costas lots of questions, but please do ask your own questions using the Q&A function in your screens. You should see it on the top bar of your screen. Ask us any questions that you like, and we'll try and answer those throughout the course of the webinar. Okay. So Costas, look, I try and use AI every day, right? In my life, I try and use it for actually coding is something that I've got to use quite a bit. I'm using it quite a bit for creating new bits of code and new processes within things like Power Automate and other bits and pieces that my colleagues will talk to you about, because I keep bugging them every day with some new flows. But looking at sort of these different trends in AI, now, what would you say has been sort of the biggest trend recently that has really moved AI forward for all of us who work in collections and recoveries? What's been the big change that we should be really excited about?
Well, I think agentic AI is probably what comes next. So when we're talking about agentic AI, we're talking about a sort of multi-layered AI. So we talked about some fundamentals. Now you'll see that we'll start using layers of AI, different levels. So we'll have different AI tools or different ML agents that will be performing certain tasks very nicely and very efficiently. So they will be experts in their own fields. And then we'll be having other layers of AI doing the orchestration or the final decision making by receiving the input from all these different agents. So these in debt collections, along with also other fields that affect financial institutions, will start appearing more and more. We've got evidence that at least 50% of the financial institutions are either already using or at least exploring the use of AI for tasks such as predictions, customer segmentation, fraud detections. It's not that much applicable in the case of debt collections, but it is for financial institutions because this comes at the pre-delinquent stage. Many different applications, and we're going to talk about similar applications later on in the discussion as well.
Okay, and I guess when I sort of talk to clients and sort of friends and colleagues who are sort of working in this sector, I mean, I keep sort of asking them, is it really AI, or is it just machine learning in a very different form? Is it just really fancy analytics that we've all done before, or is it really something new that we should be sort of taking on board here?
There's a very thin line between what is AI and what isn't. So if we go back in the old days, I said, even in the 1950s, some sort of AI appeared. So we could talk about AI. Nowadays, in the modern AI era, we tend to talk about AI for any system that has the ability to learn based on the data, based on the results it receives. So all these technologies that you see there, all of them apply some kind of machine learning, meaning that we use the output that and we compare it with what we initially predicted, what we initially generated, so as to compare and improve ourselves. So any system that has this ability, this learning ability, is called as modern AI system, if that answers your question.
Yeah, sure. And the things that we're seeing on screen here, sort of the language models, the generative AI, explainable AI, which is something that we spoke about last time, which is really interesting. Are these individual bits of AI, or do they all work together? How can we, how should we think about them? Is it, as you say, a system, or is it different components of or separate things entirely?
Well, NLP, predictive analytics, reinforcement learning, and supervised machine learning are individual fundamental technologies. Generative AI, just to give you a very a good example, LLMs, for instance, because everybody's familiar with LLMs. All you see is, asking a question to an LLM. So how LLM works? In reality, it applies natural language processing technology. It transforms the text into tokens, and then it predicts based on neural networks, which is part of the machine learning, so part of the supervised learning that you see somewhere. Not supervised, sorry, it's deep learning that we mentioned earlier, which is a subfield of machine learning. So based on this, it can predict a sequence of tokens along with a probability score. So which sequence of tokens is going to be most likely a better fit, the best fit, let's say, for the question it received. So this is how it works. So as you can tell, it uses different bits and pieces and also other mathematical or computer science fields in order to operate as a system, as you see it, as you perceive it.
Okay. Do you have a favorite LLM or one that you'd recommend that those of us who work in CNR should perhaps use more than the others?
Well, I can't make a public advertisement, let's say, but I'll give you two hints, all right? So first of all, obviously all the LLMs that you're using have been pre-trained on huge volumes of data. So the more data these companies had in order to train the models, obviously the best results they're going to generate. This is only natural. But we need to be very careful because the data that we give to those LLMs usually go to the service of those companies. So when it comes to applications for which we're going to talk later, we need to be careful because we need different types of LLMs, offline LLMs that we can safely store somewhere in our server if we're a bank, for instance, or a debt collection agency, knowing that the data of our customers will be safe and will be shared with those companies. So there are many factors that we need to consider.
All right. Well, let's talk a bit more about sort of what then, how can we use AI in collections? We've got a few examples here. Could you just take us through a few examples of perhaps where you or we could use AI in collections? And so what do you see in the market at the minute in terms of how people are using it?
Of course. So starting from the challenges, because we should always start from the challenges that customers face. We're talking about the common problems like high delinquency rates, low engagement levels, low satisfaction levels, both of the end customers, but also of our agents, because it's a very stressful job. High operational costs. So how do we address those problems? We've got some pillars, and now we're not referring to technological pillars, but to application pillars. And these pillars concern mainly predicting debtor behavior, segmenting accounts intelligently, automating communication strategies, and also some additional pillars like fraud detection that I mentioned earlier, or even compliance monitoring. So let's take these examples, for instance, that you've got on your slide there. Personalized communication strategies. We can have many different types of AI to address this problem. We can have anything from a chatbot that actually responds to the customers to very simple questions, or understanding the intent of the customer. Does this customer want to communicate with an agent? Do they want to actually pay or to apply for a settlement, for instance? These sort of things. But we can also do more complicated things like, for instance, performing sentiment analysis, like what is the sentiment of this customer, and then use these in order to map a collection agent that would be best fit for this particular type of customer. Or we can have, which is becoming also very popular nowadays, we can have transcripts of the discussion, of the communication between an agent and the customer, and use this transcript either for learning purposes to train new agents, or perhaps to, again, have a better allocation of cases per agent. We've got predictive analytics. I think this and segmentation, this is the main pillar that our customers are interested in. So we can have all sorts of predictions, such as how likely is this account to become default, for instance, or to become delinquent? How can we better segment our customers in terms of risk, in terms of behavior? Are they lazy payers or self-cure or these sorts of things? Then we've got the automation of administrative tasks. Basically here we're referring to any type of repetitive task. So we're all starting experiencing this sort of AI appearing in any kind of software platform lately. The integration of potentially generative AI and mainly LLMs, which we had a discussion earlier. We need to be very careful there because each type of AI and each technology is very good at doing certain things. For instance, if you told me that you're going to solve a problem that concerns, I don't know, predicting whether a customer is going to be lazy payer, so to reduce the communication cost, because you wouldn't have to call them, but they would pay, on their own after 3 days or 4 days of past due, then I wouldn't recommend an LLM because it needs, even if it gets a prediction right, and we'll explain why it doesn't necessarily have to, there's a lot of cost, underlying cost, and a lot of, by saying cost, we mean actual cost, monetary cost, but we also mean computational cost and many other things that we need to factor in here. But LLM is great if you want, for instance, to apply explainable AI. If you want next to a prediction to have a slot saying this prediction is generated based on this and these data sets, and it's provided to you based on this rationale. So it's a very good use of an LLM. And we also have small language models that everybody tends to forget, and they may be a very good fit actually to many of the tasks that we operate in debt collections, because they're very actually specific. So they can do specific pieces of work very nicely, very efficiently. And then we've got compliance monitoring. Well, this is a bit vague. It means that if we give some generic guidelines or directions related to the regulatory framework that we need to obey, then AI will help us basically monitor and ensure that whatever we do is always compliant with this kind of framework that we want to follow. And again, you may see some applications, especially in debt collections, that customize the responses to customers, not only chatbots, but even in processing documentation, perhaps, either based on pre-approved templates or not. So again, this is something that can fall somewhere in between the compliance monitoring and the personalized communication strategy. So we've got many different AI tools, but what we always need to bear in mind is what sort of problem we're trying to tackle.
Okay, great. We have a question here from one of our audience members. You gave an example of a sentiment analysis, thanks to AI, that a lot of sentiment. Sorry, I'm just trying to read this. Okay, looking at KPIs. Well, okay, so perhaps if I sort of start this one as an example, and perhaps you can jump in here, Costas. I did a piece of work with a client last year, looking at their systems, and I was really impressed by how they were using sentiment analysis, and what they were doing was looking at or analyzing inbound customer communications. So text and emails that were coming into their contact center, and they were using sentiment analysis to understand whether the customer was happy or unhappy, and then using generative AI to then actually suggest a response to that particular situation. And why it was really useful was because what it was doing was giving the agent a starting point of, here is a response that you could give to this customer based on what we understand not only about their history, but also about this particular communication. What it meant was the agent could then quickly amend that and send that out in a matter of minutes, rather than having to spend quite a bit of time having to craft a message with other language that might go in there, or pick a template and then start to amend it. So it was quite good. So for me, that was a real example of where sort of sentiment analysis is making and I think can make a lot of sort of improvement in the future in terms of both cost efficiency, but also productivity, in terms of being able to deal with more customer responses with less resources in a customer contact situation. Can you think of any other examples, Costas, where sentiment analysis is being used?
What you mentioned is a very indicative example. It's also a very good example of how, for instance, to use LLMs in this particular context. Another example could be to, as I said, to cluster customers based on their sentiments and either allocate them to different agents or implement a different communication strategy based on that. So don't forget that we can use some of the tools that AI, not only AI, but software can give us in general in order to also gather data about this customer. So this input can then go into this particular account, knowing that this customer, has this kind of behavioral trend. So be aware when you want to implement a certain type of communication strategy.
Well, I hope that answers your question. If not, please do ask us another question, and we'll have another go at answering that for you. Kostas, you also mentioned sort of compliance monitoring. This is something else, an example where certainly when I talk to clients, we see a lot of opportunity for. The traditional model certainly, is, for example, in a call listening, is the model where we take a sample of calls and over a month or over a week, whatever it might be, and someone listens to those and then scores them, right, and then gives some feedback to the agent or may need to resolve any issues with the case that might arise. The new model that actually quite a few people are using is what we call 100% monitoring, where AI is listening to all the calls that everyone is taking or making, and is running the listening model that's been built into the AI, and then picking up any issues for then review by a manager or a QA specialist to review. So we're now seeing, or certainly we're recommending to clients, is moving from that sample based, which is always going to be as good as the sample, to 100% monitoring, which you could argue is always only going to be as good as the AI, but at least the combination of the two, will give you far more assurance about the level of quality within your collection organization than using one alone. Have you seen any examples of things like that in your travels?
Sure. So internal compliance monitoring is exactly as you said, but we also have the external compliance monitoring that the AI can help us with. And what this would mean that, okay, not necessarily the transcripts, taking the transcript from the conversations that you just described, but even making sure that the responses that either humans or even AI itself is providing to the customers in the context of the personalized communication are compliant with those principles, that either internal principles or external regulatory or legislative principles that we want to obey to. And these applies not only to messages exchanged with chatbot, but this applies also to documentation, processes that we follow and we monitor, and all sorts of things.
Great. So this session is about getting behind the curtain, right? Understanding the real ins and outs of the realities of AI. You mentioned earlier that there are some negatives, some downsides, some challenges. Okay. If I was a collections manager, for example, wanting to sort of use AI in my collections operation, what should I really be worried about?
Okay, that's a very good question, because as you said, this is exactly what happens most of the time. So AI is becoming very trendy. So there are cases of collection managers or chief risk officers who are coming to us and say, I've been told by the upper management that the debt collection software I want to buy should have AI in it. But I have no clue what AI is. I don't know. I don't have a clue what AI can offer to me. Just, guide me. So this is a very typical example. And this is why we have, let's say, certain challenges that we need to face at this stage. The first challenge is that very often, and it's perfectly fine and normal, customers are not quite certain about what they need, what they want, but we're there to help them. Okay. The second challenge is related to the obvious one, which is data. We need data to develop good AI. AI is not a plug and play software. at least not yet. And LLMs may give you this false impression that it is plug and play, because you just log in your account, you ask a question, you're getting a response. But what you don't know is how much data has been used in order to pre-train this LLM. And also, even in this case, there's a lot of prompt engineering that you need to perform to further train it. So if you get out of this context, if you go to the other AI technologies that we mentioned, somebody needs to train them, and we need data for that. So customers should be aware that they need to share data. Of course, we're talking about anonymized data, always respecting the framework, the regulatory or legislative framework that they're following, or their internal IT policies. But we need for sure data, so they should be ready to share it, okay, one way or another, even if it's within their own environment. Another challenge, another very common challenge, as said, is exactly because AI is not plug and play. There needs to be a little bit of time, a little bit of experimentation. So we always set a threshold of what we want to achieve in terms of some technical metrics that we define, such as accuracy or recall. Probably these are words that you've heard in the past. And it takes a bit of time, it takes a bit of data analysis, of feature engineering. These are just steps in the pipeline, in the sequence of steps that we need to follow to develop and train AI in order to get to the right point when AI can serve the customer as it should. And then again, at certain intervals, we need to do what we call retraining. So all these are things that we're trying to communicate and make our customers understand, because as you said, they're not always aware beforehand.
And we've got a really interesting question here from one of our audience, which is to ask, what data points from debt collection industry could we use to train those models, and what sort of metrics could we use to see how well those models work, what their performance is?
Regarding the metrics, I just gave some examples. Usually we have some technical metrics that tell us how well we performed, but I'll tell you, we've got two different phases. We've got the preliminary phase when we train, build, and develop the model. Then we use a slice of the data set that we've used in order to test the accuracy score that we are achieving and all the other technical scores that we're measuring. But when it comes to real life, so when we go live, then of course we will be taking the real data to see how well we're doing. Now, when it comes to the data points, this is a very good question. Why? Because it gets into the fundamentals of what we were talking about earlier. It really depends on the problem you're trying to solve. Okay, when it comes, for instance, to problems like the ones that you mentioned, I don't know, predicting the type of behavior of a certain customer. Let's say if they're self-cure or lazy payer. Obviously, you need behavioral data. So payment related behavior, when do they pay, so dates, stuff like that, and also generic data. Now, this is the tricky point. The more data we have, we always need to predefine the data set that we're going to use, because that's what customers ask in order to give us access to it. But the more data we have, sometimes there's a process that helps that AI performs on its own, and help us understand a little bit which features, which data points are important for the type of prediction we're trying to make. So the more data points we've got, the more capabilities we're giving to AI. I know it's very, very hard for customers to understand that, because they want to minimize as much as possible the data to which they're giving us access. But on the other hand, we all need to comprehend that AI is very, very closely related to the data, both the quantity and the quality of data.
Okay. Was there any questions earlier about sort of whether or not sentiment analysis was fully GDPR compliant? But I guess, both EXUS and Arum are global companies. We work with clients, across different sort of regulatory
Yes.
models across the world. in your experience, what are the sort of the biggest regulatory challenges that we ought to be thinking about when we are thinking about using AI in our businesses for collections?
Well, this differs from a certain region, as you mentioned, to another. But let me say that exactly because the internal policies, for instance, we've got very big banks as customers in Southeast Asia. We've got other customers in Europe. Um, so usually and most often, the internal procedures are equally strict, let's say, to frameworks such as GDPR that are very well known to everyone, or other regulatory and the legislative frameworks. So usually, if you obey to the internal policies that these customers have, you're by far meeting also all the other frameworks that you need to obey. So there are not big differences from this perspective. What at least I've noticed is a big difference in the behavior or in the intentions of customers from different regions. For instance, in Southeast Asia, customers have been experimenting with AI since a bit earlier, so they're more kind of they tend to prefer digital communication channels in general and the use of this sort of technology, whilst in Europe there was still a bit skeptical up to very recently when it comes to using AI. For instance, when it comes to predictive analytics, there's always this kind of question, why should I share the data with you whilst I can just, I've been paying an agency to develop statistical models instead. Why do I need your predictions? And this goes down to the benefits of AI, which is interoperability with the software, the fact that you can have better accuracy scores, the fact that you can have seamless, actually, improvement of these models. So machine learning, the fact that it can learn from its own results is what we talked about it earlier, and all these sorts of things. So I think it's mainly related to the intention of the customer to give us the power, the authority to develop AI rather than the local, the regional framework itself.
Great. We have another question here. It's quite technical, so I'm going to ask you and then leave you to answer this one because this is way above my learning, unfortunately. But I'm certainly interested in the answer. Do you see the benefits using deep learning models versus the usual regression models? Do you see that these newer deep learning models truly identify non-linear data points that regression models would miss? Perhaps if you could explain what that question means first before you answer it.
Yeah. Deep learning is one of the fields, as I mentioned earlier, of machine learning. So supervised learning that goes down to regression and classification uses a different type of, let's say, background modeling in order to generate the prediction. This is a very common problem. This is mainly a mathematical problem. So this is a very good question. I think the question answers itself. By default, the kind of problems that we're referring to here, so nonlinear problems, yes, by default, in most of the cases, we see that deep learning can give better results. However, and this is something that I would like to mention, is that it always depends on the particular problem. So saying, let's say that I don't know, Bayesian neural networks, for instance, so, can give better results in this particular problem compared to, I don't know, random forest or LGBM or whatever, is a very, very generic and dangerous answer. So, and I'm saying this because we had customers, for instance, in the utility sector, you may find papers saying this particular model showed promising results when it comes to predicting, I don't know what, in the utility sector. Yes, but when we try it, we tend to identify that a different type of model that may be sometimes simpler. So it may go down to, for instance, a simple classification model instead, can give us better results. So I'm afraid, it won't be a very definitive answer, but we cannot respond unless we actually see the problem, we run the model and compare the results.
Okay.
But yes, it's true that for this particular type of problems, deep learning for sure has better potential.
Okay. So we want to try and get into sort of more of the realities of how AI is being used. And I'd like to invite you to sort of give us a few case sort of studies or examples from, the banking and utilities world, where clearly you and EXUS have done a lot of work. But I'm going to give you a challenge, Costas. Okay. I'm going to ask you to give me one example which you think is a really, really good use of AI that we can all learn from, and one example perhaps where you think it was a really bad use of AI that equally we should learn from and hopefully avoid making mistakes.
Okay,
over to you.
I'll do my best. So, in terms of the best example, and this is also related to customers' behavior. Look, people are still hesitant to fully rely on AI on everything. So sometimes they say, this is an insight actually, rather than an example, but we see that they tend to like more AI solutions that, for instance, reduce the communication cost rather than define the strategy, the whole strategy. So the closer you go to the decision-making level, the more hesitant people become. So what would be a very good example? We see that it's very popular nowadays as a prediction to offer solutions that reduce communication costs. So if you combine some predictions such as what is the best communication channel to contact a certain customer, what day, what time, and perhaps combine these with some additional predictions, such as is this customer highly likely to default or not? Then you can start forming a kind of communication strategy that, based on the evidence that we've got until now, it can lead you to an improvement of from 10 to 20% compared to the current strategy applied. Of course, there's a big gap. Okay, we can always measure the actual result, but we cannot reach the level of ROI, for instance, because what is most or the recovered amount, because that's what more customers are interested in. But because why? Simply because it's the human factor that is intervening in between. There's a human being that actually applies the strategy, and you need to ensure that they apply it correctly. But in terms of actual results, I can tell you that this is a very good example. This is a very promising kind of set of predictions that AI can provide us with, and the real evidence is showing that it's very promising. What is a bad example? The bad example is there's a very famous problem in debt collections that is called next best action. So let's assume that you're trying to predict the next best action for a certain customer using, I don't know, an LLM. At least up to this point that we're talking now, unless you actually combine different types of AI, or if you combine AI predictions with perhaps rule-based traditional systems, don't expect, let's say, AI to be able to give you such an accurate answer to this problem. So we haven't reached that far yet. So this is a bad example because you'll use a lot of computational power. You'll eventually lead yourself to poor results, and this is an indicative example of poor use of AI.
And is that back to the learning element that actually is a lot of learning is needed to understand, what the next best action is, as opposed to creating models based on, more, as you say, sort of rules-based approaches where ultimately reality will prove a rule or it will disprove a rule, but ultimately it's a judgment someone makes in
even
advance.
LLMs use machine learning internally. It's part of the elements they're using, and some models actually use reinforcement learning. So when you've seen in your LLM, do a thumbs up or pick one of the two answers that I provided you with, this is actually reinforcement learning. So you're encouraging the agents to know which one is the rewarded answer, let's say. But to cut the long story short, as you said, you need a lot of training and a lot of time actually to build a model that purely relies on LLMs to give you such an answer.
Okay, great. We're almost at the end of our session today. Thank you everyone for your questions. I guess one final question for you, Kostas, is look, what is EXUS doing to sort of help their clients or your clients to deal with or use AI? And we've also actually got a question from one of our audience as well. As a customer and user of EFS, could you share where you are mainly seeing your customers adopt AI in their collections and recoveries processes, please? So tell us a bit about what is EXUS doing, and then what are your customers using those solutions for, please?
I think my response will combine both answers. So what you see on the screen is mainly what EXUS is currently doing in the field of AI. So we've already integrated the 2 out of the 3 main pillars that I mentioned. I mentioned predictive analytics, I mentioned segmentation, and I mentioned automation of communication strategies. The last bit is in the pipeline for 2025, so hopefully we'll have it very soon. Now, when it comes to predictive analytics, we've got 2 sets of predictions. The first one concerns the customer type, the other one customer behavior. So we've got all the predictions that I mentioned as an example earlier, such as self-cure, lazy pay prediction, delinquent or default prediction, and then when it comes to communication strategy, best day, best time to call and to contact someone, and best channel to use. And also we've got promise to pay prediction, propensity to pay prediction, all these sorts of predictions that can be that can derive from the data that usually we have in debt collections. And we also have the advanced segmentations modules. So again, there's a field of AI that is called unsupervised learning that helps you actually identify cluster segments of customers that perhaps you haven't thought of, because risk-based segmentation is something that we all do more or less. So I'll give you an example on that. Let's assume that customers with blue eyes and long hair tend to pay on the 21st of each month, or tends to behave in a certain manner. So you may have never thought about it, and this kind of module will help you get some insights that will help you then refine and update your collection strategies accordingly. And ultimately, all these solutions will help you, first of all, maximize the recovery rate, and secondly, minimize the communication cost. Very soon, we'll enter the conversational AI sphere, and we look forward to sharing more news about that very soon, hopefully. In terms of adoption, as I said, we see that some very popular predictions that customers tend to prefer are the communication-related predictions. So best channel, best time to call. Sometimes also in combination with some of the fundamental predictions, such as, for instance, propensity to give a promise to pay, so that they know who to prioritize first, or how likely somebody is to become a defaulter. These sort of predictions.
Okay, great. Well, we're almost at the end of our time. I've got one final question for you, right? Which is about prediction, which is, what's the next big thing in AI that we should be looking out for? What should we be looking for next?
I think agentic AI, as I mentioned, is probably the next big thing. So we'll be having different agents performing different tasks, and all that will be orchestrated again by another level of AI that will be making decisions accordingly. So I think this is probably the future of AI. And then the rest concerns the infrastructure side, but this is out of topic, let's say, for today's discussion.
Okay, great. Listen, Kostas, it's been absolutely wonderful talking to you. I think that this is something that I think is such a big opportunity for us all, but also there's so much to learn here, which makes it really exciting. Certainly for me, talking to someone like you, who's an expert in the field. So thank you very much for your time, and I've really enjoyed talking to you this morning. And thank you to our audience for joining us today. I hope you found it useful. Hannah, my colleague, will be sending out the slides that we have used today, so hopefully those will be informative, and a feedback form as well. So please do tell us whether you enjoyed it or whether there's something that we could improve next time round. We always also look to learn and improve these things going forward. So Kostas, thank you very much for your time, and thank you very much everyone for joining me.
It was a great pleasure.
We'll see you again soon.
Thank you so much.
Bye everybody.
Bye.